Welcome to This Explainer. Today, we're unpacking the reality of the scientist journey. We're moving way past those neat little textbook definitions to look at the raw, unfiltered reality of a career in discovery. We're talking the highs, the hurdles, and what it actually takes to push the absolute boundaries of human knowledge. We're going to break down exactly what that adventure looks like, the immense challenges involved, and the massive landscape of opportunities waiting for those of us who dare to ask the big questions. So, right off the bat, we have to ask a pretty fundamental question about how you process the world. Are you actually wired for science? And look, this goes way beyond just casual curiosity. When you encounter a complex system, whether it's the beautiful fractal geometry of a leaf on a tree, or the unseen quantum mechanics that are literally powering the microchip in your device right now, is your absolute first instinct to dismantle it and uncover the hidden mechanics? That persistent itch, that relentless refusal to just accept the status quo or take things at face value, well, that's the very heartbeat of a scientific mind. If you inherently enjoy dismantling complex problems, you're absolutely on the right track. But a career in science demands a really specific psychological profile. It requires a profound tolerance for ambiguity. You need a deep well of resilience coupled with just a relentless drive to synthesize new information. It's not just about being good at math or enjoying hands-on experiments, though those help. It is fundamentally about being comfortable in the dark, not knowing the answer right away, and having the sheer determination to chart a path to your truth, no matter what. Now, you might be wondering, why subject yourself to that level of rigorous uncertainty? Well, because the payoff is just monumental. You get to engage in work that literally maps the unknown. Scientists are the architects of our modern world. They're the ones pushing us further into space, revolutionizing medicine and engineering solutions to massive global crises. Just consider historical figures like Norman Borlaug. His agricultural research is credited with saving 1 billion lives from starvation. Let that sink in, 1 billion lives. That is the literal, tangible power of this work, the unparalleled ability to alter the trajectory of human history. And another amazing thing, this career is not tethered to a single zip code. The demand for empirical research is a universal language. Your office could be a high-tech corporate lab in Tokyo, a public policy desk in Washington, D.C., or, hey, an isolated field station out in Antarctica. The infrastructure of global science means you're entering an international community where borders matter way less than the data you produce and the global collaborations you foster. But let's be totally real for a second. We cannot discuss all these exciting realities and global impacts without heavily counterweighting them with the sheer cost of entry. The thrill of mapping the unknown and operating on an international stage, that sits right opposite the reality of a demanding educational pipeline and some intensely competitive fields. It requires immense sacrifice, and weighing those two sides is just a necessary reality check. The day-to-day reality of this work is exceptionally rigorous. Beyond cultivating intense, lifelong study habits, you need the psychological resilience to handle a profession where, frankly, 90% of your time might be spent washing beakers, debugging messy code, or watching your brilliant hypothesis totally crumble. You will face failure constantly. Think about Catalin Carrico. She spent decades facing demotions and rejected grants before her foundational mRNA research finally changed the world. In science, failure isn't a dead end, it's just data. But processing that data, that requires an extraordinary amount of grit. Which brings us to the educational gauntlet. This path demands a serious, long-term commitment. Getting a university degree, and frequently a PhD, is not a quick sprint to a lucrative paycheck. It is a marathon of intellectual endurance. And earning a PhD isn't just about reading more books or memorizing facts that already exist. It's an epistemological shift. It is literally about reaching the absolute boundary of human knowledge, stepping into the void, and pushing that boundary outward by a microscopic, hard-won fraction. Once you survive that crucible of academia, you hit a critical crossroads. Because let's face it, science is just a massive umbrella term. Beneath it lies a highly specialized, vibrant ecosystem, and this is the exact moment you have to choose your specific theater of discovery. You really have to choose the scale at which you want to operate. You might be drawn to the micro, engineering human health as a medical scientist or biotechnologist, manipulating complex code as an AI researcher, or altering matter itself as a chemist. Or maybe you look to the macro, protecting our planet's ecosystems as an environmental scientist, decoding the fundamental laws of nature as a physicist, or looking upward to the stars as a space scientist. Whatever your specific passion is, I promise you, the ecosystem is vast enough to require your unique analytical talents. Okay, let's pause for a quick rhetorical reality check. When we distill everything we've talked about down to its core, what is the ultimate benefit of choosing this path? Well, it certainly isn't a lack of studying or some guarantee of easy, effortless work, and it definitely isn't the promise of being safely locked away in a laboratory, completely isolated from the real world. The true driving force, the core reason anyone actually subjects themselves to the grueling hours, the endless cycles of peer review, and the constant friction of the unknown is the profound, tangible ability to step up and solve real-world problems. That's it. The reward is the work itself, and the undeniable impact that work has on humanity. Look, we face unprecedented global bottlenecks right now that will only be broken by the next generation of dedicated researchers. The path is grueling. It demands unparalleled grit and intellectual stamina for sure, but the ultimate treasure is a lasting legacy of discovery. So the only question left to ask yourself is this: what is the one unknown you are willing to dedicate your life to uncovering?